And let me go ahead and maximize. And let me go ahead and share. Boom. Okay. So, real quick, what was the last thing that we spoke about in our notes? The only reason why I'm asking is because I teach another Math 80, and sometimes I get those two 80s mixed up in terms of where I left off. So, what's the last thing you guys have in your notes?
Word problem.
What type of word problem? Like, can you read the word problem to me?
A salesperson at electronics store sold a computer and software for $2,100.
Okay, $2,100. Okay, so let me see. That would be. Oh wow, we got that far. Holy cannoli. Okay, then that's really good actually. Wow. All right. Well, I'll tell you what. Let's do another word problem then. Okay, and then we'll move right into chapter 4 then. Okay. Sound like a plan? All right. So here we go. Oh, let's talk about this because this is very exciting for me. Okay, it relates to something I like. And yesterday, I think, was the first day that you can actually go out and buy them. So, example. Oh, let's get a black marker. No. All right, so an Xbox Series X. That's new Xbox, by the way. An
Wait,
Xbox
that's
Series
not
X
okay.
game system and several games are sold for. Let's see, the system is that much, and we'll say several games at that much. $580. Okay? All right? The cost of the Xbox Series X is 3 times as much as the cost of the games. Find the cost of each. All right. I think that works out perfectly. All right, so go ahead and do that for me. All right, are we ready? Okay. So remember, we have 4 steps that we kind of, it helps us to go through these 4 steps every time we approach a problem. Step 1 is to understand. All right. So what's going on here? No math, no numbers. Just tell me the situation.
You have a Xbox Series X that costs $580.
Okay. Well, no. See, now you're using numbers. I don't want to know that.
Oh wait, you just have an Xbox Series X.
And some.
Games.
And did we buy or sell?
Buying them.
Yeah, we're buying them. So we're buying a game console, which actually went on sale yesterday.
No, it didn't.
Yes, it did.
No, it didn't.
Was it the other day?
I looked it up. It says it's not coming out until November 10th.
But you could pre-order it.
I know.
Which means they already went on sale.
I know, you could pre-order it. It was the other day. It was
Yeah,
like
it was. I thought it was yesterday.
No.
Caroline, me and you, we're gonna figure this out right now. Xbox Series X pre-order date.
I heard about it like a month ago.
You heard about it, but you couldn't order it until.
Are you sure?
I'm positive.
No, why would they advertise pre-ordering if you couldn't do it?
Because people want to buy the newest and coolest thing, and they want to be the first on the blog to have it.
Did you pre-order it?
No, I have a PC. So let's see here. The Xbox Series X and Series S game consoles are coming November 10th. So you could pre-order it. They're coming on They're coming on November 10th. When can you pre-order? We've been waiting for about a year. But like Sony's rival PlayStation 5 console, which is coming November 12th, the Xbox Series X is almost here. So when can you pre-order? With pre-ordering started, which was yesterday.
Are you sure?
I'm positive. I'm reading it. It's on the Best Buy website.
Okay.
So yes, you could pre-order it yesterday. So if you got one, you got one. Which means on November 10th, you can go to Best Buy, or if you bought it from Amazon, it'll be shipped to you. Why, did you really want an Xbox?
I have the Xbox One X, but I want the new one,
Yeah, well, the new one sold out yesterday within minutes.
Well, now I have to go to the store, I guess.
Sorry to burst your bubble. All right? But anyways, let's get back to our problem. Now that Mr. Float won the argument versus Caroline, so I'm 1-0 today.
No, but I knew it was coming out on November 10th. You didn't say that.
All right. So, real quick, we are buying an Xbox and some games. Now, here's what we know. So the understanding. All right, so we're buying an Xbox and some games. All right, so that's the first step. We understand what's happening, okay? What's the second step now?
Isn't it translate?
Translate, very good. So we're going to translate. And what this means is we're going to try to take our problem, the situation here, and we're going to try to translate it into like some sort of equation, okay? So here's what we know. We know we're buying an Xbox and some games. So we got an Xbox plus some games. And we also know that the total equals $580. So there's our equation right there. Okay? Now this is the equation in words. Let's go ahead and let's turn this into something we would see now in a math course. Okay? So we need a variable. We're going to let x equal something. Now, what are we going to equal? What are we going to let it equal? We can let it equal the Xbox or the games. There's a better option here, okay? There's a better option. All right? You just got to be the one to kind of figure that one out. So I'm going to let you think about that for a second. I guess really what I'm asking for is this. Is there a relationship? Is there something that we know between the Xbox itself and the games? What do you think, Joe?
The Xbox costs 3 times as much as the game.
Okay. Now, do you know why I picked on you, Joe?
No.
What happened in the last class, in the previous class?
When we did our little thingy-majig.
Sure. I guess that's
Yeah.
the technical technical
Yeah.
term. So I said if the games are $1, then the Xbox would be how much?
$3.
And if the games were $100, then the Xbox would be
$300.
all right. So we're gonna let X equal the price of the what then?
Price of the Xbox.
Oh,
Or wait, no, sorry, the games.
Yeah, we let X equal the price of the games. All right.
Mhm.
So our equation now takes on this form.
Mhm.
3x plus x equals 580. Because I know however much the games are, the Xbox is going to be 3 times as much. Okay? So from here, what's our next step? After translate, we...
Solve.
Perfect. So let's go ahead and solve. So I can group like terms on the left. That's going to give me 4x equals 580. I divide both sides by the number in front of the variable term. So I'm just going to come off to the right here and just go ahead and do the division. 4 goes into 5 once. Drop down the 8. 4 goes into 18. What is that? 4 times? 16. And 4 goes into 20 5 times. So how much were the games? How much were the games?
$145.
The games totaled $145. And the Xbox totaled 3 times 145. And what is 3 times 145?
$435.
$435. Okay. And if you were to go ahead and look up the price, including tax, it's about $428. So we're a little off. But I made up these numbers. Okay? Are we good? Yes or no? Here's the thing. There is no, this is what you do every single time in terms of word problems. So we kind of give you at least a little bit of a framework. And that framework is understand the situation, try to translate it into an equation. If you have to, like right here, just use the names of the objects. All right? And then try to break it down. When you try to break it down, there's always going to be this like relationship between the two variables. Okay? All right. Then 3 is just to solve it. That goes back to chapter 1, chapter 2, and some of chapter 3. Okay? And then the last part is interpret. Give me an answer. Okay? I think it's kind of dumb if you walk up to whoever it is, your parents, significant other, whatever, because they're the ones buying you the games and the Xbox, and you walk up and you're like, hey, guess what? X equals 145. And then you walk away. I'd look at you, I'd be like, what? I don't even know what you're talking about. Now, if you walked up to me and said, hey, the games, they're going to total $145. Then I'm like, oh, okay, well, the games are $145. 3 times that amount, I can do that in my head, or I can get my little phone calculator out and figure out how much it is. Does that make sense? Like, give me a sentence that describes what we're trying to find. That's it. All right? Caitlin, you tired?
I am beyond sick.
Oh, okay. All right. Well, I hope you feel better soon. Remember,
Not COVID, but
just get some fluids and some rest. That's all you need. Fluids and rest. And some Gatorade. Gatorade's always good. All right. So, how are we on chapter 3? We good? All right, because we're done with chapter 3 then. Now we move on to Ian's favorite stuff. All right, which is going to be chapter 4. If it'll open up, there we go. Okay. And chapter 4, ladies and gents, deals with 4.1, introduction to fractions and mixed numbers. All right. So now, Maeve, what's that face for? Are you smirking?
I hate fractions.
You're smirking then. All right. Well, you know what? I'm going to be honest with you.
Hide it.
I'm going to be honest with you. If you don't like it, then you got to learn how to get rid of it.
Yeah.
Does that make sense?
Mm-hmm.
All right. So my goal then is to just teach you how to deal with fractions. That way we can just, if we encounter them, we can just figure out a way to get rid of them as fast as possible.
Yep.
All right. So I deal with fractions every day. And I don't mean by because I teach math. I deal with fractions every day because I cook a lot. For example, for my Irish folks in the crowd, I made homemade shepherd's pie last night for dinner. And it was delicious. Okay? It was phenomenal. And I'm not one of those I'll get store-bought potato or you know that whatever, that instant potato stuff. No way. I mash my potatoes. So I cut them up. I add here. You want to know how serious I take this? You want to know how serious I take my cooking? Watch this. I'll be right back. I'm going to grab some. You guys are going to laugh. All right, I am back. Here's how I take this so seriously. I made shepherd's pie, which is a traditional Irish dish. And because it is a traditional Irish dish, I use only the best ingredients. So, for my butter, for the mashed potatoes, I use Kerrygold, which is pure Irish butter. That's how serious I take this. Okay? Maeve, you're laughing very hard, huh?
Yeah. that
This
sounds
butter
good.
is delicious, by the
I
way.
know, it's good. I've had
Yes.
it.
So anyways, so within this recipe, all right, and if you want to see, hey, after class, if you want to see what my shepherd's pie looks like, I'll go get it. All right, it's in the pot still, but it's in the fridge. Within this recipe, though, this recipe is designed for 6 people. It's only Molly and myself. That's it. So I need to cut the recipe down by a third. So if the recipe calls for, let's say, a cup and a half of beef broth, I cut that down by a third because I'm not making for 6 people. I'm only making for 2 people. So, I go ahead and I just do the math real quick and I figure out exactly how much of each ingredient I need and then I just mix them all together. I watched my wife do this once and her math was 100% incorrect. I mean, it was dead wrong. However, she came up with the right answer. And I even told her, I go, listen, honey, I love you, but this is wrong. I go, but you got the right answer and I don't know how. And she was like, just let me do my thing. And I said, okay. All right. It was so funny. So when we see fractions, like I said, we see them everywhere. We really do. In cooking, all right, we see them when we drive down the road. For example, if you're driving down the road, okay, and you are in a residential area, meaning where people live, the speed limit is 15 miles per hour, okay? 15 miles per 1 hour. That is a fraction, okay? It is what that's what it is. So when we think about fractions, they are really everywhere. And the easiest way for me to kind of explain what a fraction really is another one of my favorite foods, which is a pizza. Okay? So here I have a pizza, all right? And the entire pizza, the whole pizza, if I were to count up all the slices, equals 8. So I have 8 total slices. Well, that's the same thing as a fraction. What we would say is that would be what we call, and this has a special name, it's called the denominator. Okay? The numerator would represent how many of these shaded slices I have. Okay? All right, so that's really what a fraction is. A fraction in its simplest form is a part over the whole. Another way to say that is a part divided by the whole. Okay? All right? Now, fractions normally occur between 0 and 1. All right? Now, they don't have to always occur between 0 and 1. For example, you can have 2 1/3, okay? But the idea is if we take 1 unit and then we start slicing it up into little pieces, what we're doing is we're creating fractions. All right? So, for example, right down the middle, I think if I asked you what would that fraction represent, somebody would say 1/2 because it's right down the middle. So I'm cutting the number 1 in half by 2. Okay? In between 0 and 1/2 is 1/4. And in between 1/2 and 1 is 3/4. Okay? So all I'm kind of doing here is I'm just showing you like where we would see fractions in the real world, where do they creep up and stuff like that. I mean, and all these like little things is really what I'm showing you, okay? And I think a lot of us, we've already seen stuff like this before. I think where it breaks down is when I'm asking you to add, subtract, multiply, and divide with fractions, okay? All right? Excuse me. So are there any questions there? All right, so let me kind of fast forward here a little bit in the notes because I think we can get this. All right. All right, here we go. Now we're going to start talking about types of fractions, okay? So let me get out my black marker. Does anybody know how many types of fractions we have? All right. So we have 3 types. All right. And I think you already know the answer to this. Just maybe you didn't know they had names. The first type is called a proper fraction. And it's proper because it dresses nice and it always gives you a compliment. Not really. It's proper because the numerator is smaller than the denominator. All right, and I'm going to give you a couple examples of this, all right? Here we have 3/7. That is a proper fraction, okay? 21 over 101. That's another proper fraction. A picture would look something like this. That is 1/4, okay? How are we looking so far? All right. So now, the second type of fraction we have is an improper fraction. All right, and an improper fraction is the exact opposite of a proper fraction. This occurs when the numerator is larger than the denominator. Okay? All right, so numerically, it would be something like this. 7 over 3. Or how about 3 over 2? Even 9 over 4. And what I'm going to do is I'm going to draw the picture for 9 over 4 for us. All right, okay? So 9 over 4 would look something like this. Notice I have 3 pizzas, right? But more importantly, each pizza is cut into fourths. So that would be my denominator. And then all I would do is count every single one of those slices. So in the first one I have 4, the second one I have 4, and the last one I have 1. So 4 plus 4 plus 1 is 9. So this is 9/4. Okay? Does that make sense, everybody? All right? Now, the last type of fraction we have is related to the improper fraction, okay? And this is called a mixed number. Okay? Now, up above, we'll go over what it is in a second. Okay? Like the definition. Up above, you can see that I have this picture of 9/4. Okay? I can write that improper fraction as a mixed number, and this is how we do it. A mixed number always has two components. It has a whole number out front plus a proper fraction. Okay? So if you think about that, notice with the example above, the 9/4, if I just look at the picture that I drew, and that first pizza, although I have 4 slices, I have all 4 shaded, correct? So that would mean I have one entire pizza right there. Would you guys agree? Then in the second pizza, I also have all 4 shaded again. So that's another whole pizza. So far, how many whole pizzas do I have? 2 of them. Now in the third pizza, I have 4 slices, but only 1 is shaded. And there's my mixed number right there. 2 1/4. And notice the word I'm saying, 2 1/4. That and actually implies you are adding these two things together. You have 2 pizzas and 1/4 of another one. Does that make sense? Okay? How are we looking so far? Good or bad? All right, good. So, how do we graph fractions? It's actually very, very simple. Okay? The thing we have to remember is that a fraction is a part divided by the whole. And if you can remember that, then graphing is it's very natural. So let me show you what I mean by that. Okay? So here's an example, and I want you to plot 3/4 on a number line. Okay? Now, in order for me to do this, I have to understand that 3/4 is the part divided by the whole. In other words, let me write this real fast. Oh, don't want to write that yet. All right, don't want to write that yet. So if I think about this in terms of 3 is the part and 4 is the whole, meaning how many total lines I have, what I'm going to do is in between, and this is going to sound a little weird at first, okay? So just bear with me, okay? In between 0 and 1, I need to make 4 equal parts, all right? Because that's what my whole is right here. I have 4 total parts, all right? So like right here, there's my first total part. Here's my second. Here's my third. And there's my fourth. Does that make sense, everybody, so far? Yes or no? Okay. So if you think about this, then the fractions associated with this would be 1/4, 2/4, 3/4, and 4/4. Does that make sense, everybody? So if I wanted to plot 3/4, what I do, between 0 and 1, I'm going to cut up into 4 equal pieces. I'm going to label them, and I'm just going to go ahead and plot 3/4, which is what I wanted. Okay? So let's do another example of this. Let's plot 5/7. All right. So once again, what I'm going to do is go in between 0 and 1. Now, why am I picking in between 0 and 1? Because this is a proper fraction, meaning the numerator is smaller than the denominator. So I'm not going to spill over past 1. Now I'm going to make 7 equal, or as close as equal as possible, little lines, okay? So I'm going to cheat a little bit. I'm going to do this. because I work smarter, not harder. There we go. Put a little some grids on there for me. So here's 0, 1, 2, 3, 4, 5, 6, 7. And like I said, you label them 1, 2, 3, 4, 5, 6, 7. And then in red, I'll put the decimals. Or, I'm sorry, did I say decimals? I meant fractions. So this would be 1/7, 2/7, 3/7, 4/7, 5/7, 6/7, and then this last one will be 7/7. Okay? And I'm just going to go ahead and plot 5/7. What do you think? Pretty simple? Okay? Now, let's step it up a little bit. Now we're going to plot 5/3 on a number line. Now we know 5/3 is an improper fraction, correct? So that means the numerator is going to be bigger than a denominator, which means I'm still going to go ahead and draw my number line, okay? However, I need a little bit more than 1 because this goes beyond 1. And what I mean by that is this. Look at the denominator, it's 3. So 1, 2, 3, 1, 2, and you know what? Let me exaggerate this. Sorry, I'm going to exaggerate this so you know what I'm talking about. 1, 2, 3, 1, 2, 3, 1, 2, 3. Do you see what I'm doing there? Okay. So if I were to label them again, I'll do it on top. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Are we all on the same page so far? Because like I said, I know people hate fractions. All right. Underneath, I'm going to write out their fractions now in red. So this is 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, and so forth. So I'll just finish it. All right. We wanted what? 5/3? So that's going to be right here. All right. Why are you crying? So anyways, my cat's crying now because he wants attention is what he wants. All right. So are there any questions with this? All right. We're going to do one more because I have to. Because we did a proper, we did an improper. Guess what one we're going to do now? Well, how many different types of fractions are there?
3.
And?
Mixed number.
There you go. Oh, I already wrote EX. So plot 1 1/2 on a number line. No Galileo. Nope, don't do that. It's not playtime. So we approach every single problem the same way. Draw a number line. Look at the denominator. It's a 2. So I'm just going to split them up. Okay. I go ahead and label. Well, that's going to be a 0 right there. So that's 1, 2, 3, 4, 5, 6. Okay. Underneath, let's go ahead and let's write out the fraction equivalent. However, let's write them out as mixed numbers. And this is what I mean. This is going to be 1/2. Oh, let me get out my red marker. This is going to be 1/2, and this is 2/2. Now, 2/2 is 1. All right? I don't know if you knew that, but if you think about it, if we go back to the pizza example, 4 slices, all of them are shaded, means I got one whole pizza. So I have 1/2, 2/2, which makes this one 1 and 1/2. Does that make sense, everybody? Are you sure? All right. And the next one will be 4 over 2, okay? And so forth. But right here is going to be the 1 and 1/2. Now, I'm trying to build a relationship here if you haven't seen it. All right? And if you haven't seen it yet, don't worry about it because I'm going to show you what it is in a second, okay? But I'm trying to build a relationship because there is a relationship here between improper and mixed. There is a relationship between these two, okay? And what that relationship here is this. We can convert a mixed number into an improper fraction by following this formula. Now, before I give you the formula, I'm going to write the mixed number, 2 1/4, and I'm going to show you how we get 9 over 4 from it, okay? Now, I want you to notice the denominators stay the same. So it seems like in this formula, the denominator stays the same. I'm just going to put a capital D. That'll make it easy. Okay? Now, how do I get the 9 up top? Well, if you think about it, and I'm going to go all the way back. Give me 1 second here. I'm going to go all the way back to this example right here because this is the one I'm really referring to. Okay? Notice, if I were to go ahead and start counting 1, 2, 3, 4, 5, 6, 7, 8, 9. I get those 9 total pieces, correct? Yes or no? Also, if you think about this in the lens of, or if you're looking at it through a mixed number, this is one whole pizza. This is another whole pizza. So we get 2, right? What is 4 times 2? In other words, 4 slices per pizza, and you have 2 of them. So 4 times 2 is what?
8.
8. And then you add 1 more slice to give you a total of what?
9.
Good. So the formula is going to be the numerator. Let's do it like this. It'll be the whole number times the denominator plus the numerator. And that is how you convert a mixed number into an improper fraction. So let me just show you what it looks like. 2 1/4, the denominator stays the same. Now you're going to write the whole number. You're going to multiply times the denominator. And you're going to add the numerator. So 2 times 4 is 8. Plus 1 is 9. All right. Are there any questions with that? So I'm going to give you a couple to do then. All right, go ahead and write 1 1/8 as an improper fraction. All right, what did we get as an answer? So we got 1 1/8. And what did you get as an improper fraction?
9/8.
9/8. Very good. So let's go through real quick. So the denominator stays the same. I take the whole number times my denominator, and I add the numerator. All right, perfect. Looking good? Do we need to do one more, or are we pretty comfortable with this? I think this one's kind of easy. So now the question becomes, okay, well, if we can go from from a mixed to an improper, can we go the opposite way? So I'm going to show you how to convert an improper fraction into a mixed number. All right? And here's how you do it. All you gotta do is divide. That's it. You just divide. You've already learned how to do this. Okay? It's just, we didn't really tell you this is what you were doing yet. So let me show you what I mean. We know 1 1/8 equals 9/8. Okay? So the question becomes this. Convert 9/8 into a mixed number. And how do we do that? We just divide. So if I look at 9/8, I know, excuse me, the 8 goes on the outside, the 9 goes on the inside. No, I got that backwards. I knew I was making a mistake. The 8 goes on the inside, the 9 goes no, I was right the first time. Why am I second guessing myself? I know why. Because Galileo keeps jumping up on a speaker and he's not supposed to. Come on, you got to get down, dude. Sorry. 8 goes on the outside, 9 goes on the inside. Just divide. So if we were to divide this, we'd say, okay, 8 goes into 9 once with 1 left over. Okay? Now, all I'm going to do here, you got to get down, dude. All I'm going to do here is just label things, okay? First, the 8 is going to be my denominator. Okay? This number 1, and it will always be the quotient. The quotient will always be your whole number. So that goes out front. And then your remainder will always be your numerator. And that's it. So that's how you convert improper to mixed. All right, let's try another one here. Yeah, we'll do tens. I just gave you the answer. Crap. Let me do another one here. Caitlin, give me 2 numbers.
5 and 8.
All right. Thank you, Caitlin. So rewrite 8/5 as a mixed number. Just divide. That's it. 5 goes on the outside. 8 goes on the inside. 5 goes into 8 once with a remainder of 3. So remember, the 5 is going to be my denominator. The quotient is going to be the whole number. The remainder is going to be the numerator. So 1 3/5. An easy way to check yourself, take your answer and try to get 8/5 again. Well, we know the denominator stays the same. Whole number times the denominator plus the numerator equals 8/5. So we know we're good. All right. Does that make sense, everyone? Okay, so let's see here. There's one more thing I want to go over. All right. And it's the easiest part of the day. I'm going to call them special fractions. All right. There are two special fractions that we got to be concerned with. This will take me no more than a minute and a half to 2 minutes to describe them to you. Okay. Here's the thing. You already know them. Okay. So the first one, all right, the first one is going to be when you have a situation like this. Okay. In other words, when you have a number that is the same on the top and bottom, those fractions always equal 1. It's kind of like you're saying, what's 3 divided by 3? 3 divided by 3 equals 1. Okay? Now, there is a little, I don't want to say an exception, but there is something that we need to follow. N is not allowed to equal 0. All right? Which leads me into the next one I want to talk about. Okay? If I have a number and divided by 0, that is undefined. Okay? That's why n is not allowed to equal 0, because we can't divide by 0. In fact, let me ask you this question. Does this even make sense, Maeve? If I write the fraction 4 divided by 0, what that is telling you in the pizza world is that you have 4 slices shaded, correct? But if you don't have a pizza to start with, how can you shade the slices?
Yeah.
Doesn't work that way.
No.
Okay? Now, there's an easy way to remember this. Okay? N over n is simple. N over n is 1, like 3 over 3 or 8 over 8 or 10 over 10. That's easy. That's 1. Where students get mixed up is if I give them a problem like this. I say, okay, what's 0 divided by 5? And then the second example is 5 divided by 0. Okay? This is where they get mixed up a little bit. And I'm going to help you. The top one equals 0. The bottom one is undefined. And here's how you remember the difference. You ready? If you have 0 divided by a number. Now, I'm very special. I like to highlight. And I'm going to highlight 2 letters. What does that spell?
No.
Okay, so when you read, Maeve, you read it from the bottom of the book to the top.
Sorry. On.
It spells on. Very good, okay? Just because we're doing math doesn't mean reading changes.
Sorry.
It's okay. I'm saying it's okay. So it spells on, which means yes, Maeve, you are allowed to do that. It equals 0. Okay? Now, don't think I'm done with you yet, Maeve. Here's the other side. Here's the second example. If you have a number divided by 0, what does that spell?
No.
No, you cannot do that. That's why the result is undefined. That's an easy way to remember. That's an easy way to remember this stuff, okay? Are we good? All right, so we learned a lot today. We learned what fractions are, where do we see them. We've learned how to identify proper, improper, and mixed. We learned some special properties, meaning 0 divided by a number divided by 0, and then what if the numbers are the same on the top and bottom? And then then we also learned how to convert back and forth. Okay? We also learned reading occurs from top to bottom, left to right. Sorry, Maeve, I'm just picking on you now. All right.
We did.
I'll be lenient when I look at your exam scores.
Thanks.
All right. All right. So go have a good day.